fact, on this worksheet that everybody has, letter A, you're plugging into your calculator y equals cosine x times cosine, and guess what? You don't even have to put a multiplication sign. You just put them beside each other. And then plus sine x, in parentheses, sine x. So when you put that in there in radian, what's that? Is that your, what? Okay. Sorry, that was like, did my phone fall? Did my computer do something? So we've plugged this in our calculator, and then our graph, I gotta get my graph to show. Oh, there it is. It looks like a straight line. Where? If we wanted to write an equation for this line right there. What would we put? Y equals 1. Can I ask you, why in the world does y equal 1? Because it has a y-intercept of 1 and a slope of 0. It's a straight horizontal line. Question. What's cosine times cosine? So is this really cosine squared plus sine squared? Wow. Okay. I always start off with a fairly easy, nice one. Okay. Well, let's find out. Let's go back to our graph. So y equals, now wait, before you clear, because you've already put in cosine x times cosine x. This time you can just go to the plus sign and put a minus. Sine x times sine x.
It looks like a...
Now wait. Let's let everybody put it in. Let's let me put it in. I'm going back to y equals, and I'm just going right here to that spot. Over. And I'm putting in a minus, and then I'm hitting graph. And this time, it was not -1. Because did we ever say that cosine squared minus sine squared was -1? Well, did we ever say that? No, we did not ever say that. So now, if actually, here's what we're going to do. We're going to hit the zoom button, and there's a trig. So hit zoom, and then 7. Okay? That gives us a little bit better of a picture. Everybody got zoom 7, and you're looking at this. Hit zoom. It's this button right here. And then zoom. And then just hit the number 7. And it will redo your graph to where these little dashed lines are in radians. That means that they should be at certain points. Now, if I wanted to write the equation of this line, okay, I might make some key points. Where is it when x equals 0? 1. I mean, x is 0. Or you can hit this little button that says trace. And it'll tell you at x equals 0, y equals 1. Okay? Okay? Now, if you do the arrow over and go till you, I'm not thinking quite enough, but to where it goes through, and then let's go to the bottom. Troughs and crests are important. What happens? Where is it when y is -1? Negative 1.57. Oh, what is that? What's 1.57? No. Let's keep going. Here we go. Let's go back to a crest. What happens if y equals 1? It's 3.14. No, that's really 3. No, it's pi. So if we're looking in terms of pi.
It is pi.
It is pi.
That's what I said.
You missed Ryan's comment then. 1.57 was really 2. So I was saying 3.14 was really 3. Meaning mean we don't need to round. I don't want you to round at all. Okay? So, add another another crest. We're at pi. Yes? So, when we were down low, at the bottom, is it pi divided by 2? I'm making a prediction. Put it in your calculator. What's half of 3? That's what I'm saying. What's half of 3? So what's half of 14? So 1.5. Put it in your calculator. See, it's 3.4. 3.14 is pi divided by 2. 1.57. Okay, so now my next question is.
When we were doing trig functions, we could have just used our calculator the whole time.
No. Here we go. Now I want you to actually write the equation of this line. Question, I heard Tyler say it very early, but I shushed him very quickly. So now I'm going to allow him to say it. It looks like a cosine function. Would everyone agree with that?
I was just going to say it's
No. We are very much not in the lines of squiggles. Okay? We are not in that. This is a cosine function. At 0, we're starting up. But is it y equals cosine x?
y equals
What would a negative function look like? It would start right here, and then it would go up. Oh, JC just graphed, but I really don't want you to do that. It's okay. You figured it out. Top to top, a cosine function, if you're turning around and look at your graphs, top y equals 1 to y equals 1. How far did you go? How far do you go on a normal cosine graph? You only go to pi?
Or 2 pi.
Well, it is written there. How far do you go? What is a period of cosine function? 2 pi. Right? From top to top, a cosine function is 2 pi. Is this one 2 pi?
No,
We
it's
went
pi.
from top to top, and we only got pi. So the period is different. How in the world are we going to be able to figure out our period being different? What is the period of this one? So I'm going to say the period equals pi. When we were doing graphs, what did we do? 2 pi over b. So when we were finding them, we said the period was simply 2 pi over b. Wait, do you know what the period is?
So it's just 2.
Pi. Right? So how do you solve for b? The period is pi. So pi equals 2 pi over b. So what is b?
2.
2. So what is the equation of this line? 2 cosine. Say that again.
mx plus 2.
Is this a straight line? Is this a linear function? Y equals mx plus b is a line every time. Oh, do we need to go back? Y equals a sine bx plus d plus c. Do you remember that? Is that coming back to you? Y equals cosine 2x. Your b is always with the x. It still stays at an amplitude of 1 to negative 1. So not quite as easy as that first one. The first one is a little deceiving.
What's the b in the period thing? In the 2 pi over y?
B is always the number with x.
That's what
A is the amplitude.
A is the amplitude. D is going to be your phase shift, your horizontal right and left.
And c is your vertical.
C is your vertical, the up and down.
Will we have those?
I don't know. But they will come back. We've done these in calculus. They will come back. You have to remember that. All right, let's go on to number 2. So you're writing that under f of x. Okay, and when it says f of x, is everybody okay just f of x and y are interchangeable. So number 2a, I'm plugging in my calculator, cosine under y equals, and then I have to put a 2x. Cosine x. So if you could go back and just change that piece. Plus sine 2x. Equals. Oh, and you know that you can hit second insert and it'll flash and you can put a 2? Do you know that? So I'm here with sine x, and if I put a 2 there, I have to retype the rest of it. So if you hit second and then the delete button, the INS is an insert, and I can simply hit 2 and then arrow over and not have to type anything else. Okay, so you slow down. Is everybody good in there? Okay, we should all still zoom. Is everybody good? You plugged it in? And then we're going to hit graph.
Yeah, mine doesn't look like that.
I'm going to make sure I put it in correctly. Cosine 2x, parentheses, cosine x.
So it's plus.
not minus.
Oh, I put minus because I didn't change that. I was talking about the other stuff. Sorry. Pause. That's why I go back and check. Alright, that's a little better.
Yeah.
Is that a little better?
Nope, that's not what I got.
Let's look at your y equals. Because it's on a 2x and a 2x. The second one is just x. Cosine x.
Oh.
Yeah, believe that too.
Does the zoom automatically?
It should say exactly how you had it zoomed last time. It should still say zoom 6, which is a trig.
It is.
Okay.
What was it on before?
Zoom standard. It's a zoom 6. Is that one. Zoom 7 is trig. Oh yeah, I forgot. Caitlin borrowed my calculator, and that's why it's sitting over there. Yes, sir. Your graph what?
It doesn't work fast enough.
I don't know. Have you done anything else with it? Have you downloaded games? Have you?
I'm pretty like
I don't know. I would say, is it charged? Is it? I mean, but sometimes it's just a little slower than normal. Huh? The battery is probably full. The memory is full. All right. So this graph, if we trace it at x equals 0, what is y? And somebody over here, Emily, I think, said, what type of graph does this look like again? It looks like a cosine graph, but let's keep going. It's still starting up. 0, 1. And then let's go over our trough. Did we end up at 1.57? At y equals negative 1. It's 3.14, so it is what? Pi. We're halfway there. If we get to our another crest at the top, at y equals 1, what number is that? 6.28, which we would relate to 2 pi. So from beginning to the end, not end, but trough, or crest to crest, top to top, how far is it? 2 pi. A normal cosine graph is 2 pi. So what's the equation of this line? Y equals cosine x. It's a simple, exact cosine graph. What was that look like? I don't like it. I don't get this. Why? But once you do, just keep your mouth closed. Okay? So just so you know, eventually some of you will start to catch on. Okay? There is a trick, but we have to go through them all. Nope, it's for you to discover. Because at the bottom, see all those lines at the bottom? It says, state 2 generalizations that are based on the patterns you found. So there are patterns, and you will have to come up with what's going on with them. So letter B, you're taking the exact same, and but this time you are subtracting. That's what I did the first time. So you've already got a glimpse of what that graph is going to look like. Here we go. Let's go y equals arrow over to a subtraction sign and hit graph.
Yours is so fast.
It's also on my computer. I don't know.
Pi is the bottom.
Wait.
Look.
I know it looks like that
It is two both.
because you didn't clear out the other one.
Look.
It does look like a bow tie.
Yeah.
Sideways bow tie.
I have full bow ties.
So here we go. We're going to discover.
Can I guess?
No, you guess in your head. Guess in your head. If you're writing with a pencil, you can even jot it down. But I'm going to hit the trace button. Is it still a, what type of function? Cosine, 0, 1, every time. So here we go to the bottom. 1.04, I don't recognize that one. Here we go. That one I recognize, 1.57. That's pi over 2, right? But I gotta get back to the top. Ooh, 2.09, which is doubled. But if I really want to figure it out, how could I?
Go to the next
Go to the next.
trough.
Right there.
It's pi.
Okay, so the next one over is pi. I don't know. So can I ask a question? I'm going to go back to here. So you've got that on your graph. I'm going to draw here. We started here, and we know this part right here is pi over 2. And we know we're here, and we know we're back to here. No, here at pi. Is that what you said? So there's some things we could figure out, but I want to know how far is it from this point to this point? How far am I going? Okay, so this was 2 point, is it 4 or 2.08? 0809. Okay, something like that. They're a fraction. Okay? I'm going to start having a thought in my head, and I'm just going to start plugging things in my calculator. I mean, really, I could find, well, what's this? How far apart should this and this be? I mean, and then I can find that quarter period.
Wait, so what is
Or,
what's that distance in the equation?
what do you mean? What distance?
The distance from the troughs?
Here to here?
Yes, what is that?
Oh, it's a 2.08 or 2.09 decimal.
But where does that go in the equation? Is it like the vertical shape, the amplitude?
We've only gone up to 1 and down to -1. So our amplitude is always 1.
That's your
Or-
period.
So going this way from here to here is our period, the B.
Okay.
Little hint, that's really all we're changing.
Okay, thank you.
So I'm going to go in my calculator back to calculate, and I'm going to start checking. Could I get 2.09? So if I quit, no, it's not done. I'm going to start calculating. Somebody's had an idea that it was pi divided by, not 2.
3.
Could it be 3? That's this number.
Oh,
Pi over 3 was 1.04. So if that's my halfway point, pi over 3, what's double that?
2 pi over
2
3.
pi over 3. So I'm going to go back to my calculator and see, did that work? If I do 2 pi divided by 3. 2.09. Look at that. Okay, that's why you need those decimal pieces to figure out. Okay? Now, what is our period? Let's go back to here. What is our period? 2 pi over 3. So period 2 pi over 3 equals 2 pi over b. So what is the b? The period is always 2 pi over b. This time it happens that it already ended with a 2 pi over 3. So this graph is simply y equals cosine 3x. If you need confirmation, go back here and try the graphic. Cosine 3x. Nope, that did not go like that. Cosine 3x. And graph. It just put it right on top of it. If you need that confirmation. Okay? Whew. Ready to go to number 3? Yes. Alright, next page. Number 3 was y equals cosine 6x times cosine 2x plus sine 6x sine 2x. What do you, first off, does anybody see a connection with the cosines that we're putting in and the sines we're putting in? They're the same for cosine and they're the same for sine. So go back to y equals. I'm going to clear that one. Go back up to here. I need that to be a 6. And this to be 2x. And we're adding. I'm not going to leave it as subtraction. 6. Are you coming up with a graph? Because I will make you eventually do these kind of by yourself. Don't give me that. It's a hit the trace button. Are you still x is 0, y is 1? It's still what type of graph? Cosine graph. That's not changing. This one, when I go top, all of a sudden 0.785. I can see that 1.04 again. 1.57 is my next top. If we see 1.57, what is 1.57? Pi over 2. It's half of pi. It's half of that 3.14. So can you on your own, right now, come up with the equation? I've given you what the period is. Look at you.
There's a pattern.
There is a pattern. I told you this from the beginning. But once you find it, keep it in your head. Don't say it out loud because I would like for all of us to see that pattern. Don't say the pattern out loud. Okay.
So it's 2 pi over b, and that was pi over 2, right?
Mm-hmm.
So you're left with 2 over 2, so it's just pi. I'm
Is there an
confused.
equal sign in between them?
No.
Are you multiplying?
No.
Oh, okay. That matters.
So the difference between these is 2. So is this all you need for your period?
So if I plug in a 2 right there, is
Oh.
What is your B? 4. Did everybody get B as 4?
Wait, why?
Because your period is pi over 2. Right? Top to top, you told me 1.57 is pi over 2.
Mhm.
Yes. So the period equals 2 pi over B. And you know the period is pi over 2. So that equals 2 pi over what? Your B equals 4. So this equation is y equals
Cosine 4x.
cosine 4x. Now when you go back and subtract them. Oh, not that one. Let's go back. What happens if we hit the subtraction sign in between them? Oh my word. That is crazy. You know, there actually is another way to find it. But you'd have to find 2 pi on your calculator. Find 2 pi and then figure out how many times does it repeat in 2 pi in a regular 360-degree window. And that will also give you that one. I'm going to go back. Sorry. I just thought about this. I'll put that plus back there and say graph. And then I trace it until I find 2 pi. And say how many times does it repeat. I can literally see 1, 2, 3, 4. And that gives me that 4. Another way to see it. I forget about that one a lot. Okay? So if I find on my calculator a top of 6.28, which is 2 pi, and I count how many times does it repeat. So I have 1, 2, 3, 4. It repeats 4 times in 2 pi, which is that 4 right there.
So you just have to find.
You can. That's another way to find it. And check it. So, with ones like this where they're subtracting, it might be easier because it repeats. It's very jumpy. Usually by now you're starting to make connections, and with a pattern, if you haven't yet, start thinking about it. So I'm hitting trace. I mean, actually, the first thing I'm going to do is see, do I know? Right there. Do you know the 0.78? No, maybe not. There's pi. And if you were not in Trig, Zoom Trig, these would not be these numbers. Just so you know. You got the pattern?
Maybe.
Okay. Keep it to yourself just a little bit longer. Do the next one. See if it's the same thing. Have your prediction, and then see if it comes out to
Do you
be.
have your prediction or just something that we noticed?
It's a hypothesis. Yes, you do.
Oh, I just noticed something that keeps happening.
Oh, okay. Well, that's a hypothesis. And now you're going to check. You're going to write that down in your brain or on the side what you think the next one will be. It's a theory. And then you test it.
So like I don't know the way to find them all, but I can, or like your way to do it, but I have them all.
Did you write equations? Did you go through and graph them and write equations for all of them?
Yeah.
But did you have an idea of what it should be before you did it?
Not really.
Not really. Okay, well then can you go back and put a, oh, I bet this is a connection.
But I already know the answer, so.
Well, it's okay. You already know the answers. What if I gave you a different one? What if I gave you cosine 10x times cosine 3x plus?
Do the process in my calculator and figure it out. Like I don't see a connection.
Okay, then I'm going to let you sit there for another minute. Has everybody got an equation
Figure
for
it out.
3b? See? It just takes a minute to look at it. For b, when you have y equals cosine 6x, cosine 2x minus sine 6x, sine 2x. What was your equation, Prince?
It works.
Right, just writing it down in her little lines at the bottom. What she thinks is going on. You got a prediction what's going on every time? How many times did it repeat at 2 pi? Counter. Counter toss. I mean, you're correct too. What did you count in the very beginning? Well, you're starting here. Right. So you have 1, 2, 3, 4, 5, 6, 7. So how many times did it repeat in a 2-period time? In a 2 pi, 360 degrees time. How many times did it repeat, Prince? So what should your equation be? Cosine 8x. Go ahead and do 4. If you have an idea, like there's a connection, jot it down, but then try to find the equation. So number 4, when you have, on letter A, when you have y equals cosine 3x, cosine 2x, that's a 2. Start to write parentheses in the 2, plus sine 3x, sine 2x.
That just became so much easier. I mean, it wasn't like ridiculous.
It wasn't ridiculous hard,
But now it's like.
but now it's all of a sudden insanely crazy easy. So instead of a 6, it's a 3, then a 2, and a plus sign. So 3. And if you graph, what's the equation of that one? If you graphed 4a and I traced it, how many times does it repeat in 2 pi?
Just normal cosine.
1 period is simply 2 pi. So that equation is y equals cosine x. If I want to go to y equals and I need a plus sign there, plus. Nope, minus. This is what happens when I'm rushed and I think. There we go, graph. It's because a bunch of times. So then I'm going to trace. I'm going to go over to 2 pi. How many times is it going to repeat in 2 pi terms? So if I go here, 1, 2, 3, 4, 5. And I'm going to let you go without telling you the secret. And we're going to come back tomorrow and do the back side. There is a secret. You will find it out tomorrow.
So what we just did isn't the secret?
Oh.
The sum of the coefficients is always a digit in the subtraction.